All right, we've got two more examples I'd like to go over, and I'm going to put these in the same video together because they're both what I would call the weird cases. So the first two examples I did, A and B, that's when you have a solution. And in the guided notes, they talk about what are called consistent, dependent, and inconsistent systems. So that's where, so this is example, I think, 4 and 5 in the guided notes. Sometimes you may have no solution, and sometimes you may have infinitely many solutions. So let's look at each of those cases and talk about them a little bit. This C is minus 9x plus 3y equals negative 6. And the second equation is minus 3x plus y equals 26. So again, I want to solve both of these for y. And I would get, for the first equation, let's see, add 9x, which gives you positive 9x on the right, and then divide by 3 gives you positive 3x. And negative 6 divided by 3 is negative 2. Then for the second equation, I'm just going to add 3x. That's it. Okay. Now before you even graph these, you know something about them, right? These have the same slope, but they have different y-intercepts, and equations, lines that have the same slope but different y's are, remember, parallel. And where would parallel lines intersect? They wouldn't. So already I know that there's not going to be a solution for this, but let's suppose that you don't realize that on an exam and you go ahead and you try and graph them. So for first one, I'm going to start at 0, negative 2, and I'm going to move up 3, right 1. Okay, so here's this, up 3, right 1, up 3, right 1. Okay, and I should also move down. So down 3, left 1. Whoops. Okay, so here's my line. My blue line, very nice, beautiful. Okay, for 2, this has an intercept of 0, 26, which I don't have on my grid, so I'm going to pick a different point. If I did, let's see, if x were, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If x were negative 10, then I would have that y were negative 4. I think on your grids it goes up to negative 8, right? So let's do negative 8 instead. That way you can graph it on your grid, starting at the same point. So I get 3 times negative 8 plus 26, which is negative 2. So I'm going to start then at negative 8, negative 2, and I'm going to move up 3, right 1. Again, I'm picking this point negative 8, negative 2 just because I don't have 0, 26 on my grid. You can pick any point to start and then move by slope. So negative 8, negative 2, so 1, 2, 3, 4, 5, 6, 7, 8. So right here, up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. Also down 3, left 1. Okay. Right. These are very clearly parallel. And that means they do not intersect, so no solution. And the second that you realize that, you can tell me that on an exam. If you see up here at when you solve both for y that they're parallel lines, great. You can give me a little blurb about they're the same slope, different y-intercepts, therefore they're parallel, therefore they never intersect. Okay, so this is no solution. This is what Hawks calls inconsistent. So there's no point that will ever make both equations true at the same time. So this is an inconsistent system. It cannot be a true system. All right, the last example I want to do is this one. This is 6x plus 3y equals 24, and 8x plus 4y equals 32. Same song and dance. We're going to solve both for y, try and plot them. So I'm going to abbreviate the solving for y here with, my curly arrow. So the first one, we're going to, let's see, subtract 6x, then divide by 3. That's the thing on the y. So that gives me negative 2x plus 8. Then again, I'm going to subtract 8x, minus 8x, divide by 4, which gives me negative 2x. 32 divided by 4 is 8. Okay, so clearly these are the same line. Just for fun, I am gonna graph both of them, because one has to ask, well, if it's about where they intersect, where would these lines intersect, right? Okay, so the first one, start at 0, 8. We're going to move down to right 1. So here I am at 0, 8. Move down to right 1. Or I can do 1 negative, 1 positive movement, so that's left and up. Okay, so I have this line. Okay. Finally, let's do the red. So red says the same thing, right? Start at 0, 8. Move. That was a bad D. There we go. Down to right 1. Start at 0, 8. Move down to right 1. Okay, so when you look at this, you say, okay, they're the same line, so what is my solution? My solution is where they intersect. Where do these guys intersect? Everywhere. So there's infinite solutions, and all the solutions look a specific way. They're all points that lie on this line, and we solved the equations for y. So what that means is all of my solutions look like x comma y, and the y is of this form, this right here. Okay? All right, there are infinite solutions. Oops. All of them look like x comma y, some points. It's just here at purple arrow at the top, we solve for y. Y was minus 2x plus 8. As long as x is in R. So that's your final answer. So in Hawks, you have to both say that this is a consistent dependent equation, and you have to give the form of the solution. So consistent because it does have a solution, dependent because it depends on the x value, what your y value you get out is.